So I can log this as being an outreach activity.
Cool.
That's amazing.
And
well,
do you also? Oh no, you go first now.
Okay, I was saying that maybe we should like start now, or maybe we should wait for Juan. I don't know if he's coming. If he's coming.
Or how many more people are you expecting?
But if it's okay with you, buddy, we should start now. So I don't know, maybe just start. Well, maybe
would you like to
I will introduce myself first.
Yes.
Okay.
So I'm Mariana Quintero. And yeah, I'm still in school, but this is my last year, and yeah, we're very happy to talk with you.
Thank you. I have a sheet of sort of things that you want to talk about. Where would you like to begin?
Yeah, sure. Well, if you want, whatever you want. I mean, you can just tell us. Your experience or your life or your career, everything.
Okay.
We would love to hear everything.
Okay. Well, probably you already know a little bit about me. So I am what we call an instrument scientist. That kind of is like an engineer who works in a scientific field. And the field that I work in is astronomy. So I do lots of stuff with optical telescopes. So I think one of the things that you wanted me to talk about was basically how I got there. So where did I begin, and how did I end up in the position that I'm in? Well, I mean, I don't know if this mirrors any of your experience, but when I was a little kid, I was always interested in space and stars and rockets and things, and I wanted to be an astronaut, that kind of stuff. When I went to school, I realized that I was interested in things like science. So I liked doing experiments. I also found I liked tinkering with electronics. Well, lots of mechanical things as well, but mostly electronic things. And that kind of flavored my choice of subjects when I started doing high school. We had an electronics club. I went and did some things there. And also I chose subjects which were mostly sort of science subjects, with a leaning towards physics mostly. And then I began university. And by that time, I was pretty sure I wanted to be a scientist. And I wanted to find out more about the world and the universe and everything. And I still had this idea that I was really interested in the stars and planets and all those sorts of things. I never really gave up those childhood dreams. When I went to university, I chose very sciencey sort of subjects. Those were things like mathematics, physics, chemistry, and computer science, which computers weren't really quite as widespread as they are now, but obviously it turned out to be a good choice because they're just so ubiquitous nowadays. I mean, they're just everywhere. As I progressed through university, I still felt like I wanted to be a scientist. Eventually I got to my honours year, and each year I had to drop something that didn't really interest me so much. And in the second year of university, I dropped the chemistry. I didn't really like it very much. In the third year, I dropped the computer science. Thinking back, I don't really know why I did that. But I think it's because my goal was physics, which is really how you get into this stuff about rockets and telescopes and things like that. Anyway, so in my third year, I had just had mathematics and physics, and then my fourth year, I was doing physics completely. There was nothing else. And it was very hard. I'm actually not a very strong mathematician, but it turns out in physics you need a lot of maths. So I had to work at it very hard. I did okay. I did graduate. And then there was the question of what to do next. And so by that time, I felt like I wanted to be an astronomer. And I wanted to use telescopes and find out more about the universe, this kind of thing. Well, actually, what I really wanted to be was an astronaut. But I had bad eyesight. So I'm very sorry to tell all of you that are wearing glasses, but it's very hard to become an astronaut if you have bad eyesight. So I'm sorry. It was a disappointment for me as well. But I could do the next best thing, which was to become an astronomer. And I decided that I was going to do what we call a master's degree. I don't know if you're familiar with the term master's degree over there. It's a bit like a PhD, but it's shorter. So I wasn't really sure I wanted to commit to a whole PhD. And so I just felt like I should start with doing a master's to begin with instead. The master's was, it turns out we had 2 astronomy groups in the university where I did my degree. One was a radio astronomy group, and there was an optical astronomy group. I decided I didn't really like radio astronomy. I felt like I wanted to study things that I could actually see. So I started to go with the optical astronomy people. They were building a facility in Australia. They were building a new telescope, and they needed various systems developed for that telescope. I do have a picture of it here somewhere, if I can share my screen. Is that possible? Or,
yeah, I think Leo has to make you host, so that way you can share your screen.
Okay, it's not a biggie if, let's see, where did I put it? Yeah. Let's see, over there. Okay, so let's see, share screen. I want to share that one. Okay, can you see that?
Yes.
Yep, okay. So this was a telescope they were building in Australia, and it had these little huts. It doesn't look much like a conventional telescope, but each of these little things contained a telescope. And the idea was that you could combine the light from several of these telescopes together, and what you would get is an image as if you had a giant telescope which was the size of this whole thing. So this telescope could combine the light from 2 telescopes, one on this arm and one on the other arm. And what I had to do was I had to design a system which would help these telescopes point at the right target. So the problem with mechanical telescopes is that you point them at a star, and because of mechanics, systems drift and everything, you're never pointing in the right direction, exactly the right direction, but it's almost right. So you kind of have a thing which is like a viewfinder. What I did was I built a system that would allow you to basically point these different devices, these different telescopes in the right direction, so that you could look at the star that you needed to investigate, and you could do it quickly. It was kind of an automatic guiding system, and it involved a lot of electronics design. I had to write a lot of software, and I had to get the 2 things working with each other. I could probably, let's see, end my share there. There we go. How do I do that? Okay, good. Okay, so basically there's a lot of software involved and a lot of hardware involved in that, and I had to get the two things talking to each other. And that was, it was a challenge, but I really, really enjoyed it. It took me about 2 years to get the system working. And I think it was at that point that I realized that what I really liked doing was getting computers and hardware to talk to each other. So getting computers to interact with the real world. And that was the thing that I really loved about it. So anyway, I got my master's degree. At that time, I felt like I needed to earn some money because I was a starting student. I'm sure you all know what that's like. So I went and got a job at a company that was making spectrograph equipment for prospecting. And I did that for a little while. And then I got an offer just totally out of the blue from someone who wanted me to do a PhD. This was kind of like somebody who had just seen my application for a master's degree or something. Somehow they managed to get hold of my CV. They couldn't find anybody to do their PhD. They had a scholarship set up and everything. And they just thought maybe I would like to do it. So they called me up. It was kind of a bit different to what I had been doing. It was more of a medical kind of a degree. And it was a bit weird, but they were offering money equal to what I was being paid. And I was thinking, well, this is good because I'll get an extra qualification, like a full PhD. People can call me doctor. So I decided to go with it. Things kind of got a little bit strange after that. Perhaps I shouldn't have listened to that way of thinking. So what it was to do with was heart research. And it was research into defibrillators. I don't know, have you heard what defibrillators are? You know when somebody has a heart attack and the paramedic comes along and they have the two electrodes and they put them on the chest and they go clear. That's a defibrillator. But some people, if they are at high risk of heart attack, they can have a defibrillator put inside them. So it's always there, ready to give them a shock if they have a problem. And my PhD job was to try and optimize these things. So they have two electrodes, they are implanted inside a heart, and I was trying to figure out what the best positions were for those electrodes. So in this case, what I was doing was mainly a computer model of the heart and the electrodes and the electric fields. So that was where my physics background was useful. And I was trying to optimize the positions. So I wrote a program that would do all of that. I had to do some experiments on animal hearts, sadly. And I just didn't like it. I got the PhD in the end, and the work was useful to somebody, I hope. But it wasn't really, at that point I realized that it wasn't really what I wanted to do. So I went back to the astronomy group. There was an opening at the telescope facility where I had been, so I returned to them for a little while. But then they ran out of money. You will find this if you go into academia, to university projects, is that money is always a problem. So sometimes you get funding for things, sometimes you don't. It just depends. Well, the thing is that there's no profit in astronomy, right? I mean, nobody's going to make money out of selling papers about exoplanets or anything like that. The only reason people fund this kind of thing is, well, I guess it's prestigious for governments. And often you get a lot of spin-off technology from that kind of thing, but As a business model, it just doesn't work really. So they ran out of money. They had to let me go. So I was looking for a job, and it turned out there was an opening here in the United Kingdom at Cambridge University. And they also had a telescope, a lot like the one that I had been working on. And they also needed work done on that one. And I will see if I can find a picture of that one for you as well. Let's have a look. Okay, I will try to share my screen again. That one. Okay, you can see that. Yep, okay, so
Yes.
it's the same kind of idea. Yeah, it's the same kind of idea. Lots of little telescopes, they're in an array, and the light gets combined together as if you had a giant telescope that was that size. So, I'll stop that. Okay. So, what they needed doing was a system very similar to the one that I had done at Sydney University. So they had 5 telescopes and they all needed to be pointing at the same star. So it takes a long time to do that if you're doing it manually. So I constructed a system to do that automatically. So with every telescope, I had a little camera in, and I had some software that would read the images out, and it would tell the telescope where to point to center the star that we needed to do. So we were doing that for a little while, and then the group that I was working in, they got involved in an even bigger project in the United States, where there were some people in New Mexico who wanted to build a much bigger telescope. And I will show you a picture of that one too. Let's have a look. Okay, so this is getting serious now. The telescopes are getting bigger and bigger, and there's getting to be more of them. So this is at a site in New Mexico. Some of this is not actually real yet. This building is real, and this telescope is there now as well. So this is all under construction. And I was asked to help develop some of the technology that was to be used in this telescope. And one of the things I was asked to do was to construct a, let's see, no, I'm going to have to close it. I need to find a picture of what I had to build. It is a slightly funny photo, so I will show you. Where is it? There it is. Yeah, so this thing is kind of we call it like a torpedo or a trolley, and this thing sits in a pipe inside that long building that we were talking about before, and it moves along the pipe back and forth, and it does some of the work involved in combining the light from all those telescopes. And I designed some of the electronics in this device, some of the antenna layouts. There's an embedded computer in there. I wrote the software for that. There's a number of actuators and things that move the mirrors around in here. There's various sensors as well, like temperature sensors and position sensors and things like that. And so I did a lot of work in getting this thing to run. And once again, I was doing the thing that I really love doing most, which is getting computers and hardware to talk to each other and move things around and sense what things are doing. So I really enjoyed this project, and this one is actually now installed at the telescope, and it's functioning very well. So anyway, that was the first project that, well, the second project that I worked on after I joined them. But there have been many more. Let's have a look here. So, so I told you about the original acquisition system that I built at the first telescope that I worked at. And then there was another one that I built at the second telescope that I worked at. And it turns out that I had to do a third one as well. It turns out that I am the world expert in acquisition systems for stellar interferometers for the sort of telescope that I tend to work at. And this was the night that we got ours working. So it wasn't just me, there were a lot of other people who worked on it as well. But this was the night we got it working. It had to do a few other things as well. It had to take the, it imaged the starlight that we were looking at, and it had to adjust a mirror very quickly. Like it had to tip the mirror around very, very quickly in order to compensate for the wobbles in the starlight that are caused by the atmosphere. So the air is all very turbulent, and this was a way of correcting for it, as well as acquiring the target. So that's kind of an overview of the sort of work that I have done to date. I'll just leave you with one more, which is the sort of thing I get to see when I visit the site. So that gives you an idea of the sort of telescopes that I was working with, and there are many of them. So that kind of is the kind of thing that I have done, and how I got to where I am. And it's kind of the sort of thing that I like doing now. So it kind of goes from when I used to like tinkering with things as a child, and then getting interested in science and in computers and things, and eventually becoming a career in getting computers and hardware to talk to each other in a scientific context. I'm very happy in the job that I have, but I won't ever be rich and I won't ever be powerful, but I am very happy. So I guess that's kind of an overview of what I've done, and I don't know, any questions? What would you like to talk about?
Hello, Bodie. Yes, I actually have several questions for you.
Okay.
The first one is, can you explain us a little bit how those telescopes work? Because I can see they're not the same telescopes as when we think about a telescope, we think about, you know, like the normal telescope with a scope, and you know, it's not the same one.
It's totally different.
So how does this telescope works? And
Okay.
And
Okay.
how complex are they?
They are very complex, much more complex than an ordinary telescope. I'll just pull that picture up of the biggest one again. Okay, so what you have is a lot of telescopes like the one that I was standing in front of. So each one is in a little dome like they are here. And what we need to do is we need to take the light from the star. You can imagine a starlight is falling into each of them. And we need to combine that light together as if the whole lot was a lot of, I guess like a whole bunch of little lenses, like a whole bunch of little lenses of individual telescopes. And we're kind of pointing them together so that the light from all of them ends up in this one place. somewhere in here. But there's a big problem with it, doing it this way. And the distance has to be exactly right. So in here, what I didn't really talk about very much, there's a whole bunch of those trolleys that I showed you, those torpedo things. And if you could imagine that light was coming from a star over here into this telescope, and then it sends a beam of light into there, and then light was coming from a star over here and sending the light into there. This light has to travel further than that light does, and that's wrong. It doesn't work if you do that. So what we have to do is, with this light, we have to send it all the way down here and then all the way back, so it travels the same distance as the light from this one. And if you do that exactly right, to within a micron, like to within a millionth of a meter, then it works. And if you do that with lots of telescopes, then it's a little bit like having a giant telescope that's that big, but you don't have to build a giant telescope that's that big. But the individual telescopes are a lot like a conventional telescope. So that's kind of an overview.
So this makes it cheaper, or?
A lot cheaper. It also makes it possible. So if you had to build a telescope that was this big, an optical telescope, you could not do it precisely enough. The mirror for a telescope has to be made very, very accurately, to within a fraction of a millionth of a meter. And if you were to build a mirror that was that big, then it would sag if you were holding it at an angle. It would bend, it would warp, it would buckle. If a bit was warmer than another bit, then the surface would ripple a little bit. It's just impossible. But we want to have a big mirror because the bigger the mirror, the sharper the image. And you can see much more clearly what you want to look at. So this is kind of a compromise way of doing that, that you get the sharpness of your image, but you don't actually have the complexity of having to build a giant telescope that's the size of the whole thing. So it kind of fuses the light from lots of little telescopes together to do the same job. But because you have to send the light in here, and you have to extend the time it takes for the light from this telescope to get to the detector, everything has to talk to each other. All the telescopes have to talk to each other and to all the machinery in here. It's a lot more complex than a conventional telescope. And so there's a lot more hardware and software involved. And I write a lot of the code in getting all that stuff to work.
Wow.
Yeah, like I say, it's a challenge, but I'm very happy with the work that I'm doing.
And what's the most interesting thing that you have seen through those telescopes, or in the past years?
Well, that one I just showed you is still under construction, so it hasn't seen anything at all yet, except, it has seen a star, but it was just a star, so it wasn't very interesting. When I was in my master's time, I did some observing with the telescope there, and I did discover that there was a star that was actually a binary star. It's not really very exciting, but there was a star that people thought might be a binary star, but they weren't really sure. And so one night I happened to be doing the observing that night, and I just realized from the data that was coming out, there was actually a binary star, which is two stars that revolve around each other very closely. And the thing is that with an ordinary telescope, you can't tell because it just doesn't have the resolving power. But with these kinds of telescopes, they have much sharper vision. So you can see that this kind of thing is happening. And in that case, that is the most interesting thing that I think I saw. I discovered a binary. Not very exciting, but it's something.
Actually, it is for us.
Yes, of course. Bodie, I would like to know how is a normal day, like the day by day from of an astronomer. How is it?
Well, I don't do much actual astronomy anymore. But when I was, it was actually not so much a day-to-day life as a night-to-night life. So, so what we would do is we would go out to the site, and then we would, I guess, stay up the first night, and we would have an observing program decided on, and we would point the telescopes at whatever we wanted to look at, and we would take the data. And you can tell a little bit about what you're looking at from the data, but it really takes some processing afterwards to find out what's really going on. So, so typically we would do the observing, but we wouldn't really know very much about what the result would be. And then we would sleep during the day, and we would work at night, and we would do that for about 2 weeks. And then we would come back to Sydney, where I lived, and another team would go up and do the same kind of thing. And so we would have 2 weeks there and 2 weeks back. And when we were back at the lab, we would be either analyzing the data to work out what was really going on, or we would be working on new hardware to put in the telescope. Or sometimes we would be helping the people who were there if they had some problem or other, so helping them to sort it out. And then we would be back up the telescope again for our 2-week shift. It didn't always go very smoothly. Sometimes things would go wrong because it's a very complex instrument and it's all being built by us, so it's not a commercial product. So things would tend to go wrong quite often, and we would often be able to fix it at the time and try and save the night's observing, or sometimes we would not, and we would have to work during the next day and try and sort it out before the next night's observing. So that's what it was like then. Now I don't really do much observing because we're in this construction phase. Before the lockdown, I would tend to spend maybe half my time in an electronics lab or a dark lab, trying to get electronic stuff to work. Or maybe the other half of the time I would be writing software. After lockdown, my day is mostly just writing software because that's what I can do without going into the lab. So that's what it's like.
Thank you. It's very interesting. I also would like to know, Bodie, I had a question. I forgot it.
It's okay.
Do you have questions? The other guys, maybe?
Yeah, I have a question. Well, I assume that it's very difficult to like make all these telescopes work like at the same time and to work very well. I assume it has to be very precise. So what is the biggest challenge for you to make these telescopes work well?
Oh, okay. The biggest challenge is getting the software and the hardware to do what they need to do fast enough. So because of the precision is just impossible to accomplish just with mechanical parts. So if you were to build a telescope, the mechanical parts would drift. They would never be in the right place when you need them to be. So what we have instead is we have parts that don't have such quite high tolerances, but they are active components. So we have mirrors that can steer, or they can push and pull, and they can do it all very quickly. the challenge, the hardest part for me, but also the most satisfying part when I get it to work. So sometimes you have the air doing this kind of thing. It's just messing everything up and it's doing it very fast. Okay. And you have a mirror that's trying to unmess it. Okay. And I have a detector somewhere in the middle that is trying to work out what this mirror has to do. So it's got to get an image of the star. It's got to calculate what's wrong. It's got to tell the mirror what to do. And the mirror has to do it fast enough that it has matched what the air did. So that is probably the most challenging thing, is to get those things to work fast enough. For me, anyway. And I did it. So that you know, that picture of me standing in front of the big computer screen, I was very happy that night because I had proved it would work.
That's amazing. So if one telescope I don't know, it doesn't work, they don't all work. I mean, like it's all messed up or something.
I think when the whole array is commissioned, and we have 10 telescopes there, if one doesn't work, it's not that big a problem. What you would get is a degraded image, slightly degraded. So you can actually get an image with only 3 telescopes, but you need to spend more time doing it. So in fact, that's probably what we'll be doing to begin with, is that when we have 3 telescopes there, we will start making images. And then as time goes on, we'll put more telescopes on their pads, and then the images will improve, and we'll be able to get them faster. So yes, I suppose it's kind of a redundant system, that if one is not working, then you can still do work, useful science.
Oh, okay.
Mm-hmm.
Thank you.
Mm-hmm.
Hey, Bodie, I remembered my question. Finally, I know what happened, but I liked something that you said, that was, I won't become rich or powerful, but I'm very happy. And
Yes.
I like that, because that means, so I could understand that you are your work is your passion now. So
Indeed.
I would like to know if you recommend to go for your passion, or maybe what did you think when you had the chance to take the decision? What was your analysis?
I think I didn't hesitate, actually. I think I knew that this was what I wanted to do. I shouldn't give the impression that I'm poor. Okay, I'm not poor. They pay okay. I mean, I live comfortably. There's lots of things I cannot afford, but it's okay. I have a very nice house with my family and things like that, and it's I'm comfortable. I never have to worry about feeding myself or anything. So that really is enough money for me, and I do feel that how to put it. I mean, that there is a common saying that if you have a job that you love, then you will never work a day in your life. And it is a bit like that for me. That I mean, I'm being paid to play with these incredibly expensive toys that I could never afford myself. I get to be that kid, who liked tinkering with things, but with all this really expensive stuff. And I'm just really, really happy when I get something to work. So, I mean, with my degree, with the physics degree, I could have gone into banking or the stock market or that kind of thing, but it just didn't really appeal to me. It didn't really have the hands-on thing where you can use a screwdriver or a soldering iron or write some code that interacts with some sensor or detector or something. It just didn't have the same appeal for me.
Buddy, I wanted to ask you, like Leo told us a couple weeks ago, you work at the Mullard Observatory or something, and I did my research a little bit, and I found out this guy Martin, let me look again, Martin Ryle. He won like a Nobel Prize and everything, and I wanted to ask you, what do you do there, and what, I mean, I found out about a 5-kilometer telescope or something.
That's right, yeah.
It's really interesting. So I wanted to ask you about it.
Yeah. I'm not really involved in that side of things very much. So what Martin Ryle did, so you remember earlier I was talking about this concept of having a couple of telescopes and you combine the light from them to make an image. Well, he had the same idea, but doing it in the radio. It was first done in the radio. So he had the idea that you could take a couple of radio telescopes and you combine the radio waves from them and that you can get an image. His big innovation, it was really clever actually. You remember that that picture that I showed you, all the telescopes were kind of spread out all over the place. Well, his idea was, well, why don't you put the telescopes in a line, just one after the other, and then what you can do is you can point them at the star that you want to look at, and then you wait for the Earth to turn the whole array around, because it's on a spinning Earth, right? So the telescopes, if you're at the star looking at the telescopes, they're all kind of rotating around. So he reduced the idea of having a giant telescope to just a line of single telescopes, and then you could have them in different positions looking at the object just by waiting for the Earth to turn them around. So the whole thing about combining signals from lots of telescopes at once was his idea. And the facility that I worked at, they were basically just trying to take that idea and do it with light instead. So that's where the connection is, that we're both in the same group, but we kind of came to it a bit later, and we decided to work with light and not with radio waves. So it becomes quite a different engineering problem if you do that. There's some other famous Nobel Prizes from the group as well. So there's the discovery of quasars, for instance. We were actually in a, I'm actually very privileged to be able to work with these people because they have an amazing history. They have a lot of Nobel laureates there. Sometimes I'm just happen to be, well, before lockdown, I used to be just sitting at a coffee table and there'd be a Nobel laureate who just sort of sit down with us. At the moment, I work with a Nobel laureate. One of my PIs is a Nobel guy, so he won the Nobel Prize last year. So it's actually amazing to be able to work with these people.
And do you feel like, is it like it is competitive to like this area, or I mean, your job?
It's a little bit competitive. There are there are perhaps 2 other facilities worldwide that do what we do, and they're a lot more ahead of us with this kind of work. So we're basically trying to do a better job than they are when our telescope is complete. We think we have a better design because we've learned from the arrays that I worked at and from some of the designs that they have made, and we think we have a better one. So in that sense, it is a little bit competitive, and of course we're all competing for grant money as well. But it's not really that competitive. It's not really a cutthroat industry where someone sends the boys round to the other group and punches their heads in or anything like that. We all go to conferences and, we talk about our stuff, to each other. We're not keeping anything secret or anything. It is kind of cooperative in a way as well, that we do ask each other, how to do stuff. It's kind of a friendly rivalry.
Buddy, I have a question, but it goes a little bit further back. So you said that you were not good in mathematics, I think, but you were studying physics, right?
Yes.
So how did you get over this mathematic problem and try like to do better or something? Like, what was your inspiration to do it?
I just studied really, really hard. I knew I wanted that physics degree. I didn't want to embarrass myself by failing, and I just needed that degree, and so I just thought, well, I just have to do the maths. I was originally doing harder stuff than I originally started with the hardest possible course, realized I couldn't do it, to deal with it, and I dropped back a little bit, but it was still sufficient. It was really just because I really wanted that physics degree that I stuck with the maths. So I compensated for my lack of talent with a lot of study, just going over it over and over again, and just working really, really hard at it. That was all it was.
Okay, great. But did you end up liking mathematics?
Some parts of it, yes. There was a section on complex number theory, which I really enjoyed, and it's actually really useful when you're doing engineering as well. So that was something that I really enjoyed. I remember when I did the exam for that subject, I got so into it that I was just going through all the questions and everything. Oh, I know everything, and I just got so absorbed in it. I was just before the last question, and then the end of exam bell went, and I realized I just lost track of time. I had gotten so into the questions for the exam. So it was just that one subject in mathematics that I really enjoyed. The others were mostly a hard slog. Having said that, since I decided to go more down the instrumentation path after that, and the engineering path, I found I didn't actually need to use the maths very much. And to this day, I actually don't use it very much anymore. Some of it, but none of the really high-powered stuff. So I guess it was more a means to an end rather than anything that I would find useful in the work that I do now.
Buddy, I have another question. You told us you dropped computer science, and now I can see why you ask yourself, like, why you did do that. So you just learned all of that by facing it, like trying out, or?
Well, the first 2 years of university, I did do computer science, and it did help me a lot because it taught me about structuring computer programs and how they work generally, what a function is, all these sorts of things. And then, like, as you say, I don't know why I dropped it in the end, because I use it every day now. And so when it came to start my master's degree, I had to do programming, and I basically taught myself as I went along. So there wasn't really any formal course for it or anything. It was a different computer language to the one I had learned before. So there was no course or anything. I just had to learn as I went along. But that's one of the things you do in a graduate degree is a lot of stuff you just have to learn in order to do what you need to do. And I found it was something that I enjoyed again, and that I was good at. So yes, it was just picking it up as you go along.
Buddy, so like, could you give us an advice? Because I mean, sometimes we don't do things that we like to do them, but we have to do them. And as we can see, you didn't want to study, like you didn't want to do mathematics, but you have to do it. So
Yeah.
could you give us like an advice to find this motivation to keep going and do things like we don't want to do at the moment?
I think it's just the end goal. I think you need to know why you're doing it, and if you if you think, well, I can't stand this stuff, but if I do it, I will get this thing that I really, really want, then I will do it. It's just it's looking at the long-term reward. I think if you have a bit of a plan about what you want to do, and if you know you need something to do that, even though you don't like doing it, but you're willing to put up with it because it gets you where you want to be, then I think you just have to keep telling yourself that you need to do this because of what you want in the long term.
Okay, yeah, I think that's a good advice.
There is actually another example. The PhD, it wasn't really my favorite time when I was doing this medical research. And but I knew that if I had a PhD, I could do many, many more things. In science, it's really important, if you want to work in research, to have a PhD. So again, I stuck with it, and I didn't really like it very much. And there were some days which were just just terrible. Other days were good, but I knew that if I had a PhD, that it would help me a lot in having a scientific career. And as it turns out, when I got this job here in Cambridge, one of the requirements in the job application was that you have a PhD. It didn't matter what it was in, but you had to have a PhD. So if I had not done all of that work, I would not have the job that I have now. So there you go.
And what has been the most difficult moment for you, like in your career or at the time you were doing your PhD?
Oh, the PhD. I don't know. Let's see. There were difficult moments. One thing I really didn't like, but I told you we had to work with animal hearts. So I had to do an experiment on a dog. It was a dog from the pound, and we had to do tests to see whether this defibrillator would work well on the heart. And it basically involved sacrificing the dog, and the poor dog, they anesthetized it, and we had to do surgery on it. And I didn't do the surgery. I wasn't allowed, but I was there, and the poor dog was whimpering away and everything. It wasn't properly anesthetized and whatever. And I was thinking, I don't want to do this. I don't want to hurt these poor animals. So that was when that was a difficult moment, that one. Yeah.
Okay.
And in your life, which has been a difficult moment for you?
A moment that was not work related. Let's see. Truth. There haven't been very many really super difficult moments. There was a time when I was, I've done a lot of part-time jobs that I haven't told you about. So one of them was, I was working to make a bit of cash before I started my PhD. No, after I finished my PhD, because I was burnt out, and I decided to become a sales representative for a microscope company. And every day I would wake up and think, I really can't do this. I don't know how to do this. I mean, I don't know how to go over to people and tell them, try to convince them to buy a microscope. I mean, it's, and I had nightmares. I had, I had nightmares about falling every night. And it was stupid. It was just a sales job, but that was, I suppose that was a difficult moment. I was thinking, do I want to do this with my life? What am I doing? So perhaps that's an example. There were other difficult moments, a more personal nature. With my daughter, when my daughter was born, she was very, very ill for a long time. Actually, I nearly lost her in the first few moments after she was born. I nearly lost her, and I nearly lost my wife in those moments. And so that was a difficult time. And our daughter was very sick for years after that. And, every day, you wonder, what would happen next. So that was a difficult time as well. Happily, both of them are well now. And, our daughter is really something. It's just great to see her growing so much. So that's probably a good example of a difficult time in my personal life.
Buddy, I'm gonna change the topic a little bit. Okay, the time we talked to Tanya, I also asked her about this woman who discovered these pulsating stars.
Yes,
in
yes.
Spanish, pulsares. And she told us the story, like how she didn't win this Nobel Prize and everything. Like, were you related, like, to this topic? I mean, you were working there maybe, so you heard of it, or I don't know.
Oh yes, it's very well known in our group. Yes, that's Jocelyn Bell is her name, and yes. Before we got locked down, I used to give regular tours out at our facility, and part of that was the facility that she worked on, the facility that discovered pulsars. And we tell everybody the story, but I have to try and do it in an unbiased way. I usually say something like, some say that Jocelyn Bell really should have got the Nobel Prize for that work. And it was criminal that she didn't. I really think she deserved it. She really should have got it. I wasn't involved. That was long before I got there. But it is an important part of the history of our group, the discovery of pulsars, and that particular story is something that people always ask me about. So are the rest of you familiar with the story?
Well, Tanya told us like a little bit of how it happened.
Yeah. So she was a graduate student at the time, and she made perhaps the biggest contribution to the discovery of pulsars, because she was looking at all of the data, and then realized that these regularly pulsing things, whatever they were moving across the sky, so they couldn't be terrestrial in origin. She was pivotal to that discovery. So she really should have at least shared that prize. Now she's perfectly okay. She's still around. She's perfectly okay with not getting the prize, because what she says is that when you get a Nobel Prize, nobody ever gives you any other prize ever again, because how can you beat a Nobel Prize? But she gets lots of awards all the time. I mean, people keep inviting her to things, and they keep giving her prizes and stuff for her knowledge. She wouldn't have all of that if she got a Nobel Prize. So she's perfectly okay with it. But a lot of people do get offended on her behalf. And I personally think that she should have shared in that. They were different times back then. I think nowadays probably she would have shared in it. At least I would hope so. So it is kind of a scandal, as close as we can get to a scandal in our group, I guess.
But I have another question. I'm sorry, I'm full of questions today.
No, fine. Please, please.
But well, I wanted to know, what do you think is the next step, like for like of astronomy, like the next steps of those telescopes, or how big can that go? And yeah.
Oh, well, let's see. Well, there are many fields in which astronomy is progressing. So the once our interferometer is built, it will be probably the highest resolution instrument in the world. Beyond that, people are already talking about larger arrays of telescopes. So some people are talking about a giant array that is many kilometers in size. And that array would be, I think, in South America, somewhere in Chile. And that array would be able to resolve exoplanets. So you would have such sharp vision that you would be able to look at exoplanets and see if they had continents on them and things like that. So that would be pretty amazing if that comes to fruition. But that is a very long way down the road, and that's not going to happen for a long time. The really sexy thing at the moment, sort of thing in astronomy, is gravity waves. So you may have heard that people have started building observatories that they don't use light and they don't use radio waves, they use gravity to observe, and they can observe things like merging black holes and all kinds of really extreme events. And there are 2 facilities online, and there'll be a third one I think is coming online soon. And those 3 facilities will be looking at the universe through gravity waves. So that's probably where that kind of thing is going at the moment. There's also space telescopes are improving all the time. There'll be one launching in a few years called the James Webb Space Telescope, which will have a higher resolution than Hubble. And there's another field that I completely forgot to mention, which is exoplanet detection. So you may have heard in the news that we now know that there are planets around other stars. And one of the things I have become involved with quite recently is detection of these planets. So there are several groups who have that they've built instruments that can detect exoplanets, and I'm involved with a group that is going to build the most precise of these. So the hope is that it will be able to detect planets like our Earth around other stars, which would be very nice. So those are probably the highlights, I guess, if you like, as to where this kind of work is going.
That's great. Thank you.
It's really, really cool to be part of it, actually, to be watching this develop and to be able to participate.
Yeah, I wanted to ask you, like, what do you want to do next? Like, do you want to keep working on this, like building these telescopes and the system, or have you thought of changing? Like, I don't know.
I'm pretty happy with what I'm doing. So I like working with telescopes, and I like this thing that I get to work with the robotics of them and the computers and everything. And I like that it's an academic environment, so it's not as stressful as a commercial environment. And people give you a bit of time, extra time to do things if you need to. The field itself is always changing, so there's always new stuff going on. So I'm always doing new things, even though I'm still in the same place. So, you know, I started on with these acquisition systems and then moved on to these delay line trolleys. And then there's the adaptive optics systems, and now there's this terrestrial planet finding stuff. So the field is always changing, and there's always new stuff going on. So I'm quite happy where I am, and I'm really not wanting to change fields very much. It could still happen though.
Can I ask a question? Hello, everyone.
Hi, Tanya.
Hi, Tanya.
Hi.
I just have a question, honey. Do you remember the, you know, the Large Hadron Collider? You know, the data that they produced. There is this big particle accelerator in Switzerland.
Yep.
I know that the data that they will produce is quite important for your job. You know, it will, in the sense that it will provide information as well that you can use. If I remember correctly, last time we spoke about that, there was a problem with the data, that it just didn't match, or they couldn't reproduce the data. And you know, it was a huge scandal, because it's one of the most expensive projects in physics, right? Or am I wrong?
Oh, it is the most expensive one.
It is the most expensive one. And I remember there were problems with data there. What happens to that? That nobody has followed up. Well, nobody can be COVID-19 nowadays. But what happened to that situation, that they have the data, it wasn't what they thought it was? Remember that they were gonna break one of the laws of physics.
Oh yeah. I think I know what that was. There was an indication that that they were studying neutrinos, which are these little particles, and they seem to be traveling faster than light. So they had the accelerator there, which is on the border between France and Switzerland, and they were sending neutrinos to a detector in Italy somewhere, I think, and they seemed to be arriving there before they got sent. So they're thinking, oh, is this new physics or anything? And they seem to be traveling faster than light. That seemed to be what was going on, and they started getting quite excited about this. But being scientists, they want to be very careful and carefully hedge their language and everything, because you don't want to make sort of sweeping statements before you're sure. So I remember that now. It actually turned out to be one of the instruments that they were using to detect the neutrinos. They traced it to a bad connector. There was a thing they had to plug in.
It's just to show you that it happens even in the best families. You know, this type of mistakes, you know, they have all the technology in the world to avoid this to not happening, and still it can happen.
Yes. Yes, there are a lot of failure points. A lot of things can go wrong.
They haven't spoken about this ever again. No, nothing has been mentioned.
Quiet, isn't it?
It's like nothing happened. Like, put it under the carpet, right?
Yeah,
like,
Well, it turned out that it was just a bad connector, so the neutrinos weren't traveling faster than light, and it was all.
And then you can imagine the laugh that these guys have when they realize that.
Yeah.
It's just a smile in your face that you feel like, oh.
Yeah, but they did it the right way. So this gives you a good idea of how scientists often work. That they didn't say, oh, we found something which is going faster than light or anything like that. What they do is they say, our data looks a little bit strange. We'll write something about it. Maybe you can have a look and tell us if it makes sense. So they got people to have a look at it and everything, and it all seemed to be like it was the neutrinos were traveling faster than light. But they didn't want to make any official announcement or write an official Nature paper or something like that until they checked everything very carefully and eventually traced it to this connector. And then disaster and international embarrassment was averted. So they did the right thing. They didn't make claims that they weren't sure were true. they relied on the facts.
I don't know if someone has a question.
Well, there were some questions on this sheet that were sent to me. I don't know. Some of them I have answers to. Should I go through them or?
Yeah, sure, if you
Whatever.
want.
But then before you do that, I just want to tell you guys two things. I guess, you know, he's very, when he talks about that he's bad in math, that's not true. You know, that's not true, because you can see his whiteboard full of equations. Remember in your book of algebra, he does all these calculations like they were, you know, sums, multiplications, or divisions for us. Yeah.
Oh, it's
so
high school maths though.
that's, imagine that's the level, that's high school math for him, but it's not. And I think he's not, he might not be feel that he's very good at maths because his father actually happens to be a professor emeritus in statistics in the University of Sydney. So of course that, you know, the level will be never ever there. He says he doesn't know math, but that's not true. You know, he is the perception, you know, when you have standards, this, yeah, but he is perfectly okay with math. Believe me when I tell you that. So that's fine. And the second thing is that when you were asking about difficult moments, the most difficult moment in his life was when he was sitting in the terrace of my house in Valledupar with my three brothers, and they were drinking whiskey with him the first time that he met my family. That was his most difficult moment in life, I can tell you. Just to you know, he forgot. I don't think he had forgotten about that, but that was one of on the list, in the top 3.
I learned to love the old path.
You learn, yeah, the right way. Anyway, that's all what I have to say.
There were some questions here, like it kind of asked me about my work experience, and then what key learnings has this experience left you? And I wrote down 2 things. One was find a job that you really, really like. So we've kind of been through that already. And the second thing is, if it doesn't work out, just try something else. I mean, you're young. I mean, you've got time. I mean, the PhD was kind of a bit of a misstep, but just went back to what I liked to begin with. And I mean, it's okay to try stuff if you're not really sure. I mean, you've got time to try something else. Let's see, what else was there? Was the that we haven't already been through. So one of the questions was, what's your position of leadership? I'm obviously not a leader, so I'm just a team member, but it asks, what do you think a good leader is? And for me, I can speak from experience that I have a very good leader who is in charge of our group. And the reason I think he's a really good leader is because he does all the political stuff. He does all of the stuff about getting funding and everything. He doesn't let there be any office politics. He keeps all of that stuff at his level and lets me get on with doing my job, the thing that I'm paid for. So he's kind of like, the best thing about him is he's a shield. He's like a superhero that shields you against office politics and people climbing the corporate ladder and all this kind of thing. It's just so nice to have that. So from my point of view, that's what a good leader is. Book recommendations. There's a thing on here about book recommendations. It depends. I mean, if you're considering a career in electronics or electrical engineering, there is one book which is the Bible for us, and it's a book called The Art of Electronics by Horowitz and Hill. I can send an email or something with a link to the website. There's actually a website for this book. It's that famous, and pretty much every electrical engineer in the world will know this book. So it's kind of a bit old now, but unfortunately it's on my shelf at the office, and I can't go to my office because of COVID-19. But when I was there, I used to look in it every day. It's a very good book, and it's a really good way of teaching yourself about electronics if you decide to go that way. So I think that was about it in terms of the questions that I was asked that we haven't really already covered.
Yeah, I have a little question, but first I wanted to thank you for your definition of a leader, because that's the first time we hear something like that, and I think that's really nice for us. And my question is, how do you manage to combine your work time and your family time? Because you told us when you're observing things and stuff, you have to stay there during the night and sleep during the day. So how was that?
Well, it was difficult for a bit when Lorena was born, because she needed so much attention. One thing is that I don't do so much observing anymore, so that's less of a problem. And it's mostly I just have a day job like anybody else. And because it's the university, they don't really mind how you organize your time. So you can not come in until midday, and then you work until 7 or 8 at night, and then, or maybe you're an early morning person and you work really early, or you work a bit in the morning and then you go home, and then you bash away at your keyboard until midnight or something. And they're perfectly okay with that as long as the work gets done. So it's become quite flexible now that I'm not observing anymore. Where there can be an issue is because this facility we're helping to build is in the United States of America. So I have to fly there for 1 or 2 weeks at a time, perhaps. And that means that Tanya needs to look after Lorena on her own. At the beginning, that was quite difficult. Sometimes she got her mum over to help out. But perhaps Tanya, you'd like to talk a bit about how you managed when I wasn't around.
You really don't want to know, honey. You don't want to know.
It was tough.
Yeah.
But the nice thing about the university is that, again, they were very understanding when I had to take time off to rush home if Lorena was sick or whatever. So from that point of view, it's actually a very good job to have, that it's flexible, and if you can't work as well as you would like to because of family issues, then they're perfectly okay with that. As it turns out, my boss, the guy who keeps, the superhero boss who keeps all of this stuff away from me, he also has family issues. He has a mum who has Alzheimer's, and she's not very well at all. So he understands totally what it's like. And it's just really nice to have that support. And so for me, it's been made a lot easier by the support that the university has, basically. So I guess the answer is I worked less when there was trouble, and the university was okay with it.
It is, if I might, honey, I just would like to add that we are very privileged. As you say, the university is quite understanding, but it's just, I guess it's just the quality of work that you get when you treat your employees well, is worth all that investment. Here, the maternity leave is 1 year. My boss needed me to go back to work before a year, you know, because we have a project ongoing and there were other groups working the same thing that we were working. And, you know, in academia, it's all about who publishes first. So we were already advanced in my project and we needed to publish. So Lorena was sick and I was she was 9 months old, and there was no nursery here or that could receive her because she was that level of sickness. You know, she really required proper attention. So through the university, there are programs that support the researchers to go back to work in any way they can. I say, well, I would like to go to work, but there is no nursery in Cambridge that can take my daughter. And then she asked me, can your mom take care of her? I say, yes, of course she can. So through the university, she made the case that she needed me back to work, and the university have to pay the tickets to my mom to come and help me take care of my child so I can go back to work. So it's that level of commitment, you know, of the employee and the employer to help in situations. So my mom was already here, you know, for obvious reasons. But, you know, she will say, my boss say, well, you know, your mother needs to be here. She did the paperwork and she bought the university bought the ticket to my mom to come and take care of my daughter for a year. So I could go back to work. So, you know, the care that the university has for its employees is quite good, and it is extremely reasonable. I have to say that we are privileged in that sense. I don't know if any university in Colombia or in Latin America will do that. You know, give a maternity leave from 9 months or 1 year. I think it's still 3 months, the maternity leave in Colombia. They introduced now paternity leave, right, Hon? So I think you took 2
Yes.
weeks. They gave you 2 weeks when Lorena was born.
That's right. And I think that's been extended now as well.
Yes, it has been extended, I think, to 45 days.
Yeah. And I think we can, you can divide it up as well. There is longer leave that you can divide between the mother and the father as well. Now, I think, however you want. Also, we've experienced this more recently with the lockdown. So with the lockdown, Lorena's school had to stop and we had to do remote learning. So our daughter was at home and I was pretty much her teacher every day. So so I was teaching her for all of the mornings and some of the afternoons as well. Most days, because Tanya had to go to the lab, but I was able to work from home. So I was able to do that. And so it meant I couldn't get much work done. So sometimes I would work at night, you know, when Tanya came back, but there's only so much you can do to make up for the work that you haven't done during the day. And so, I mean, I mentioned this to my boss, you know, that I'm really sorry, but, you know, I've got to teach my daughter. I can't do anything about this. And he was perfectly okay with it. No problem. No problem. We'll keep paying you. Don't worry. So it was actually really nice. So it is a very good place to work.
Buddy, I had a question, and now that we're talking about the lockdown and the COVID-19, were there projects that were delayed or something like that because of the situation in the pandemic?
All of them. Everything. Yeah, so the project in New Mexico, basically they had a stop order, I think in March. They also have a funding issue, so it wasn't just the lockdown. But basically we were told to stop working on the project totally at that time. But my boss said, well, I mean, we've kind of been paid to do this stuff, so we should continue it at some level. But really all we've been able to do is continue working on software, the side of things. It's nice that there is so much software involved because it means we can do a lot of stuff. it is the kind of project where a lot of stuff can be done remotely. But ultimately, we're going to hit a brick wall, and we're just going to have to start working with real hardware again. So the entire project has been delayed by perhaps, well, at least 9 months. It'll be perhaps a year by the time things pick up again. Other projects that I'm working on, well, there's the Terrestrial Planet Finder project, which is still going ahead at some level, but there's still no lab work being done with that. So that's kind of been delayed again, maybe about 6 months or so. But pretty much all projects the university is involved with have been delayed because we weren't allowed in for months. Lab workers are allowed to go in back now because they have to, but the rest of us are still working from home. Yeah. So it has messed up a lot of stuff everywhere.
Yeah, I can imagine.
Yeah. But we all still have our lives and our health, so we must be.
Yeah,
grateful.
that's the important thing.
Yeah. Yeah, the university is really taking care of us as well with that. They have really strict measures in terms of working to keep us safe. Because they have their own facilities for COVID testing, it means we can kind of bypass the national system. So if we need testing, we can get our tests faster. So not just us, but our daughter can. She's allowed to use the university system as well. So it is quite nice. They're looking after us. I guess they don't want us to get sick, because if we get sick, we can't work. So it helps everybody.
It's quite impressive how
Yeah.
everything works. It's a little bit different here.
Yeah.
Yeah, but yeah, I wanted to ask you something, but just out of curiosity, do you, like at your workplace, do you sometimes have students like as interns, or is it too advanced for them?
No. There is a program. So from about third year, we take students for the summer vacation to do short projects. And we also have master students and PhD students, and they actively participate in the development of our projects. So it's a lot like what I did when I was a master student, that we have instrumentation that needs to be built, and we get people to build it and learn along the way. And it works quite well for us, except that one thing I will say is that there's actually a shortage of people who want this kind of career, interestingly. So when people want to get into astronomy, mostly they want to do observing, and they want to use existing telescopes, and they just want to get their data and write their papers. Or alternatively, they want to do theoretical astronomy, where they're really good at physics and they want to find a new theory of dark matter or dark energy, or something to do with cosmology or something like that. So we actually have very few people, very few good people who want to develop instrumentation for telescopes. And it's actually a big problem, because telescopes are getting more and more complex, and they need people who can do that kind of thing. So if any of you are thinking of going into that kind of career, then you perhaps will be looked on quite favorably. But anyway, yes, we have, from about the third year, people start getting involved in our research projects.
Cool. Oh, well, I don't know if anyone has like any other question.
Well, I just want to add to this point is that the university is working really hard promoting this area of science in girls. in women, because there is a extremely I mean, they are not represented at all. And I still don't understand. Well, I think in my humble opinion is, I don't think the girls need to be stimulated to it. Yeah, because you know what you want to do. I'm sure you already have these little voices that are telling you from the very beginning, what do you want to do in life? Yeah, that little, like Bodie wanted to play with expensive toys. He knew that from the very beginning, yeah? So, like I did as well, I remember I knew exactly what I wanted to, but for me it was impossible. So I pictured that it happens, this is what happens to women, that they don't talk, or they make them believe, you know, I mean, I think Leonardo will be the best one to find the term, but it's something very subtle that they don't tell you, it's not told, it's not spoken about, but that's the rule. Yeah, like the girl, if you, for example, I have 3 brothers, I was supposed to be the one to stay home to take care of my mom, but guess what, I didn't. So, you know, so that was supposed to be my job. And then when I left the house, that was what people start thinking, like, you know, why is she leaving? She's supposed to stay here. So the same thing happens with this area, that they think that why? I am a woman, so why would I do that? Why would I even consider physics? You don't, as you see, you don't have to be good in physics or in mathematics, but if you like it, you will find a way to do it. So I think it's that it has been seeded in our minds as girls, that that's something that perhaps we shouldn't even try, or it doesn't look good, or is not, you are not supposed to even consider. So here they are begging girls, you know, they are all, any kind of fellowships to study physics. And the thing is, the trick is that you can use that as an advantage, because, you know, you don't have to be bright and have the best qualifications in math. You can use that career to do something else, you know, even to do biology. You have no idea how much I want to, they have projects that they combine physics and biology. You know, when they say the bacteria or all the experiments to the space station, so they are combining all kind of subjects with physics, you know, to try to attract people, especially girls, you know, like even fashion, you know, these fashion designers who the kind of, believe it or not, it is important for the astronaut, you know, the right type of fabric, you know, the right angle of the clothes, whatever, that's fashion, you know, architecture, and all these things can be related to that area in a way that you don't imagine. So I think, you know, if I was 20 years old or just finishing my high school, I will jump so fast on those fellowships that without, even though, you know, even if I wanted to do makeup, you know, you need to learn about what, you know, how to make cosmetic to last longer in UV radiation, for example. Yeah. So I will use that fellowship to do, you know, to end up where I want to end up. So that's one of the things that I will say if I will be the spoken person for the physics department. But, you know, that's a hole there. There is so much money, many fellowships, that you don't have to have the best course in high school to get it. As long, you only have to have the availability, you know, the mental disposition, the physical disposition to go through the program, and they will help you, because these people is amazing. You know, these people, they want you to learn about that. So it's one thing to consider, that the girls, they should apply or should take advantage of those opportunities.
So if you get a a university degree or a master's degree or a PhD, it definitely does open a lot of doors for you. So there's a lot of jobs that will become available to you if you have those qualifications. On the other hand, it is possible to do very well without any of those things. Just really depends on what you want to do. But for the sort of job that I have, it would have been impossible to get this kind of job without following that path. There's no way, no, absolutely no way I could be doing the job I do now without those degrees.
So if someone has some questions or no, what do you say?
I have a question for all of you.
Please.
Go ahead.
We do that too.
Do you have, are you starting to get ideas about what you want to do as a career?
Well, I'm not 100% sure, but I would like something with like business, but I'm still considering going like to another country to study or staying. I'm really not sure. I don't know what advice could you give me so I can maybe decide or something.
Well, I can already tell you that your English is phenomenally good, so you would have no problem at all in an English-speaking country if you decide to do that.
Thank you. Well, yeah, I'm still considering, so we'll see. But I would like to do something with like marketing or business.
Yeah.
I think that's what I want to do.
Yep.
Nicolás, Majo.
Buddy, I have to tell you, because Mariana's very good at designing things. Very, very good.
Good. Designing things is very creative activity.
Yeah, it's cool. I like it too.
For me, even sorry?
No. Go ahead.
Okay. So for me, even designing a piece of instrumentation, like a detector or something like that, I find it a very creative activity as well. It's like building something. So I get the creativity thing. It can be in places that are not where you expect.
That's right. Hey, Nicolás, do you want to say what you want to study?
Yes, I wanted to study economics here in Colombia at the University of Los Andes. I think one is also studying there, economics.
Yeah, I'm studying economics. I'm in first semester, so I'm a freshman.
Well done for getting there.
Thank you. But actually, I wanna work in something like business. I wanna be an entrepreneur. So economics it's okay for me. I mean, I like it, but business is the main thing that I want to do. So So I don't know yet if I'm gonna stay in economics or if I'm gonna change to business but we'll see.
Well, when I was an undergraduate, I chose subjects that allowed me to go in a couple of different paths. So I had the flexibility of being able to drop things when I realized they weren't for me. So
yeah, I can do that as well.
Awesome.
But as I told you, I'm in first semester, so I'm currently just studying the main topics and the main classes of my career. So
well done.
Thank you.
No worries.
Well, Bodie, I am already also at university. I am studying literature, so it's quite like the opposite of science and all of this, but I also find it really interesting. And
they're all valid. They're all valid careers. They are all valid career paths.
Yeah, and I'm in the second semester, so that will make me also a freshman. But yeah, I'm learning a lot, and I am interested also in I mean, we're getting like kind of involved in all these education things and stuff, and that's really interesting too. But what it's closest to my heart is being a writer, I guess. So I would love to do that with my future. Yeah.
Our daughter is showing signs of being a good writer as well. maybe you both will become great writers.
Yeah, maybe.
And I like arts, and I like architecture, but I also like business, and I think I could be an entrepreneur, but I'm not sure. But I'm thinking.
He's
Actually,
also very good at designing.
yeah, he is. We were actually talking about that with Pache 2 days ago or yesterday. I don't remember actually, but we were talking about what he was going to study, and I told him like, man, you should study or even
Politics, you said?
or
Yes, I also like politics. Yes. Oh, like many different things. That's the problem. But I like to paint a lot. But I also like other things, very very different things. So I have to think. I have 1 year.
and he
to
makes
think.
amazing videos. He's
Yes, I also like to
incredibly
make
good at
Yeah.
videos.
He's the videos
That's
guy.
right.
Wow.
I'm kidding.
It sounds like you can do
That's
anything. Sounds like you can do anything, whatever you want. It's great.
No, I'm not sure. If I can do anything, but
It-
I'm still thinking.
His
Maybe
multifaceted.
business works for everything. Maybe like
Maybe, yeah.
yes. So I don't know.
I don't
Maybe
know.
Colombia or Spain. I also like Spain.
Yes, let's see.
I don't know if Santi Tejas wants to tell us.
Yes?
See, Tejas is here, isn't
Are
it?
you here?
Yes, hi. Can you give me please a second?
Yes, no problem.
Well,
We can hear you.
in the meantime, we can tell you a little bit of what we do here.
Yes, please.
So this is actually like the main part of our program, like Punto E. It's basically this what we are doing, like having a conversation with someone like you, that it's that we think and we know that you are first of all an incredible person, and secondly a very good professional in your field. And also now we are having how do you say that, forums, like we do like huge events. The last one we had an event of 20 hours of live stream. It was also with interactive activities, and yeah, it was basically that. It was called creando, which means creating. So yeah, so Santi can talk right now, and I can tell you later everything what we do, if you're interested, obviously.
So hi, Bodie. It's a pleasure.
Hey.
For me, this hour was very, very interesting. So thank you so much for your speech. And yeah, sorry, I was attending a call with my grandfather, but yeah. So I'm a student of the Colegio Andino, and now I have a clothing brand, and I also like to read and do some sports. And I will be a lawyer in the future. I don't know if I will stay here in Colombia, study, or to do my final job. But yes, in this moment, I'm like choosing my life and opportunities and what I'm going to do. So yeah.
Santi Tejas is the youngest.
Yes, of the group.
I think it's wonderful. There's such a diverse range of interests, and I think it's just wonderful. I mean, it just came into my head there is, again, it's kind of like a saying that, you know, it's from a movie, I forget which one. Tanya might be able to help me out. It's Antonio Banderas, that's right. And in one of those scenes, he looks at his students and he says, you know, I look at you and I see opportunity, and so in potential, and just sort of so much that I can see is going to happen because of the work that you will do with your lives. It's just wonderful to see you all at the start of your careers.
Thank you, buddy.
Thanks.
And
Well, yeah, maybe Juan can tell you more about all of this project and all of the things
Okay.
we've been
Yes.
doing.
well,
Okay.
it's just basically a forum. We're just developing the idea. We want to have a virtual world for the next forum, so you can buy stuff and you can interact with other people in this world. We also want to have rap battles. I don't know if you have heard about them. They're very very well. They're very cool actually, and it's a trend here in Latin America. And we want to have some sort of activities to make a virtual life like differently, because it's boring to have the same thing every day. Like there's a forum, there's a person speaking about something, but it's not interactive. It's always like it's the same speech. So we want to have different speeches. We want to have different activities. We want to make like this new reality, this new life, more fun, if I may say that. And yeah, we want to kind of change the ways to do virtual events.
It's kind of interesting for me it's kind of interesting for me as well, because one thing that Tanya and I do from time to time as professional scientists is we go to conferences. I'm going to be going to a conference in December, but it's going to be a virtual conference now. And it's kind of interesting to find out how it might be possible to manage something like that and still make it interesting. Because all we're going to be doing is I'm just going to be sitting in this office here and I'm going to be watching videos on a computer screen. So it's interesting what ideas you might have to make a meeting interesting online.
That was a question?
Yes.
So first of all, what we do or what we did, it's to have short like speeches. So first of all, hold on. I have to have my ideas clear. And so we have three like parts. The first one, it's an Instagram, which is where all the kids were. So we had a 5 minutes Instagram live. So the speaker told us about who he was or who she was. Also a little bit about what she was going to tell us in the main stage. So then after that, the speaker went to the main stage to do a speech of 18 to 20 minutes, in which we as the presenters or organizers kind of interview the person, or if the person had a speech from herself or himself, he or she could do it. And after that, we had like a Zoom conference with all our media partners and all our like other speakers and persons that we knew that were like very interested in these topics. So we did like these three things. So the speaker first went to the Instagram page, then to the main stage, and then to the Zoom conference. It was like 35 minutes, something like that the speaker was speaking, and yeah, it was basically like that. We also had like different stages. Like we had a stage in which we did a little bit of workout. We also had the rap stage in which people could interact and or could like participate in these activities and rap a little bit and have fun with each other. And also we had like trivias, and so we asked people, okay, what's the biggest country in the world? And that's a random question, but I think you know what I mean. And we did some giveaways so people could be a little bit interested in what was happening. And what else did we do? We also, and I think that was all. I don't know if anyone. Oh, and also we have the virtual world that we already talked about. It's the like the part that we want to develop more, and it's like the future of our event. I don't know
Yeah,
if someone wants to add something.
yeah, I wanted to ask you something, buddy. Are you gonna like organize the event or are you gonna speak at it? You're gonna be a speaker, right?
Bodie?
Are you asking me?
Yes.
Yeah.
Yes.
Yeah, the question was for you.
Oh no. You talking about the conference I mentioned.
Yeah.
No, I'm not organising it.
Okay.
I don't get to have any say in how it goes. So
Yeah.
I'm just presenting a poster there. That's all.
Yeah. Okay. So what I wanted to say is, I mean, it depends on like what the topic is and what your public is and everything. But what we felt is that people have way more engagement with the speaker when you start off telling something about you or what you do. You know, like what happened here.
Okay. Yes, I get it.
So I think it might be useful for you if you start off something doing like something like that.
Yeah.
I will
Okay.
pay money to see astronomers rapping. I will pay £1 million to watch that myself.
Of course.
So, come on, sweetheart. You have to propose that in your next meeting. I pay the ticket, whatever the cost is.
Should I learn to beatbox?
Beatbox.
That would be really
Probably,
funny.
why not?
Watch.
No, but really, I have to tell you, it's a huge trend here in Latin America. Like millions of people are doing that and watching that, and it's like rap. It's the future.
Wow, we've
Yeah,
hardly heard
it's
anything
really
It's kind of
cool.
sad, but it's how it is.
I've heard nothing about it over here at all.
Yeah,
It's
I
like
guess
it's
lots
like
of
a
young people do things.
Yeah.
Go ahead.
It's all right.
no, don't worry.
There's a lot of stuff that young people do here that I don't know anything about either.
Country is very stiff for that kind of things. You know, they are very square and very formal and very. I doubt that will. I mean, when this gets here, I don't know, something will happen. Perhaps.
No, but you want to know something? I was there, like in the UK, 4 years ago, and I don't know what it was. I can't remember, but I went to I don't remember in which city
Notting
it was.
Hill, the carnival in Notting Hill is
No. Well, no, I was talking about like I just got there and there was this park and they were having like a huge breakdance like competition and stuff, and I was like, wow, that's great. So
oh no, London is very cultural. You know, yes, you know, you can find here anything. They will dance anything. They are very open to that. But what I mean when it comes to introduce all the things that you mentioned in a scientific conference, you know, good luck with that.
I know, I know.
No, of course,
Yeah.
this is like mainstream stuff.
Yeah, I think there's probably not going to be too much beatboxing at the conference I'm going to, sadly. They're very dull people. They have a if it had been in real life, they would have had I think a conference dinner and then maybe a tour of the whatever city it was going to be in, and that's about it. And then we all have to talk our science. It sounds like yours is much more fun.
Yeah. Well, I think it's getting a little late there in the UK, so maybe I don't know, we should like go finishing this. Well, yeah, but it was a pleasure to talk to you. It was really interesting, everything that you told us. I mean, everything was amazing. We learned a lot in this meeting. And yeah, it would be also a pleasure to have you here another time with some other people and like the new generation that is Maria Jose and no, the old generation, yeah, the big ones, and that are Maria Jose and Juan and Nicolas that is not here, another Nicolas, and they have this project that is Líderes.e, like I don't know how to say that in English, but yeah, and they also do these meetings, but in different groups, and it would be also a pleasure to have you there, so you can tell them your story and I don't know what you told us today. It would be a pleasure. So you're more than invited.
It would be my pleasure as well. Well, as I've mentioned, it's actually part of my job. I'm supposed to be advocating for or telling people about what we do. I'm paid to do that, and it's impossible to do now because we can't show people around our observatories or our labs or anything. So it's a wonderful opportunity. I'd like to do that. Thank you.
Well, yeah, that's amazing.
You,
I don't know if someone wants to say something.
We have also two guests here, Juan Felipe Penagos and Johan Nunez. I don't know if they want to ask you something or say something.
Or maybe introduce themselves.
Yes, of course.
Or if Leo had something to add or to ask or.
No. Thank you, Bodie, for your work, for your time, and for your conversation. Really a pleasure. Thank you for your time.
Everybody.
Hi.
Nice to meet you. I was consciously listening to the conversation and to the very interesting questions that everybody in the room was posing.
I know they're really bad, aren't they?
I actually tried to be silent, to learn, to listen and learn. Probably in the future we'll meet. I hope so. When the pandemic lets me. Let's everybody actually.
Yes.
Well, I'm just amazed of everything you've done and your research. I was stalking you a little bit on the on the internet, but I actually it's pretty hard. I tried to Google your name, but it only appears something on Cambridge. So I would like to read some of your papers. So if you can,
okay.
Where can I find them?
I don't have very many. I can send you links or something, perhaps. Yeah, there's not very many because I don't actually do much research. I work more on the engineering side, the instrumentation side of things. So I do have a few technical papers. I can send you links to those, but there won't be very much in the way of scientific papers.
Great.
Anyway, I guess Tanya has your email address and everything.
Yes, of course.
Okay.
Yeah.
Okay. I'd be happy to do that.
Thank you so much.
Well, guys, if someone wants to say something else, has something else, or if not.
Well, no, I don't have.
Leonardo,
Let Bodie
can you
go to
please
sleep. No, let Bodie go to sleep. I think it's really late in UK.
Okay.
Oh, it's just midnight. But Leonardo,
Just midnight.
just,
It's fine.
Leonardo, please.
I'll just say something. I'll just say something
Yeah.
that I just want to say something. I just really enjoyed this. Okay.
Okay, thanks.
Apart from,
Thank God.
anyway, I keep saying this, it's a professional thing I'm supposed to be doing and everything, but I actually really enjoyed it. So thank you very much for the opportunity.
Thank you to you for your time, Bodie, and I want to see you again another time. Really, really, is possible.
It'll be my pleasure.
Thank you, buddy.
Appreciated it.
Thank you very much, everyone.
Thank you, buddy.
Yeah.
Nice
Thank
to
you.
meet
Thank you, buddy. It was
See you again soon.
amazing everything. Okay, well,
Okay.
see
Bye.
you.
Hi, buenas
See you.
noches.
Bye.
Buenas
Bye,
noches.
Tania.
Tania.
Chao,
Bye.
chao.
Bye, Tania.
Bye,
Chao.
bye. Leonardo, avísame cuando los primeros tiquetes London-Bogotá, please.
Sí, por supuesto.
Necesito
ahí te
esa
escribo.
primicia, por favor. No hay nada en el horizonte.
Nada en el horizonte, pero te digo 20 de octubre. Por ahí más o menos, pero te aviso,
Ok.
te aviso inmediatamente, tengo un dato por ahí interno.
Cool. Bueno, un besito
Ok.
a todos. Que
Ok,
descansen.
feliz noche.
Chao, Tania,
Nos vemos.
muchas gracias.
Gracias.
Chao, Tania.
Bye.
Hey, guys.
Oigan, estuvo espectacular. I loved it.
Me encantó.
¿Alguien puede parar la grabación para que esto pues,
Sí,
no-
la buena.
Ah, sí.
Uy,
¿Cómo se para?
mucho
Creo que es
piloto,
Leo el que la
man.
tiene que poner.
Ay,
Lea,
Leo
bien
se
ahí,
pisó.
bien ahí. Estás muy atento.
Yo siempre. Bueno,
No,
muchachos,
pero
estoy
Leo
aquí.
se pisó.
Nos tenemos que
Ay,
ir.
Estoy aquí, pero desde la universidad. No, a mí me encantó. Yo no sé si ustedes se aburrieron o algo.
no, fue de
No,
mis
para
favoritas.
nada.
No, cero.
Estuvo
Excelente.
demasiado chévere. Me
Ahí
encantó.
estábamos lanzándole preguntas.
Yo no
Sí,
me
estábamos
imaginaba, oigan, sí,
bombardeando.
las vi muy bien. Yo no me imaginaba ese telescopio en el piso acostado así todo. Yo cuando
Yo
me
menos,
mostró
ese
ese
cuando
primera,
yo un telescopio.
dije, ¿qué es esa vaina, hermano?
Muy
No,
chévere.
estuvo
Todos-
muy Además, fíjate que me encantó. Ahí me estaban contando por interno que él está feliz. Bueno, además se vio y lo dijo.
Se
Me
notaba.
parece. Así que
Sí.
toca usarlo, toca usarlo porque de verdad saben que es lo que él hace súper interesante. Yo creo que vale la pena. También pensando en que fíjense que estimular a que la gente elija también física, elija otras profesiones en nuestro país es interesante.
Sí.
Y si contamos con gente como él, que lo dice de una manera tan apasionante, sería muy, muy bacano. Sería una cosa muy bacana contar con
Total.
Sí,
personajes.
totalmente.
Gracias por descargarla a todos, por el error de la semana pasada, lo logramos.
No, sí, re bien, chill.
Tranquilo,
chill.
Ferre.
Sí,
Súper
relajadísimo.
Antes
No,
no, igual, creo que, ves, los tengo que dejar, me tengo que ir, creo que Pache también se tiene que ir
Sí,
conmigo.
tenemos
Sí,
comida.
yo también me tengo que ir.
No.
Ah, sí, tú también, Mari. Pero
Sí, yo tengo esa reunión con ustedes.
sí, estuvo muy bacano, la verdad, me encanta verlos, muchachos.
¿Tienen reunión de qué?
De
De
un
una
comité.
cosa del consejo.
Conectandino,
Chéveres.
¿cierto?
Bueno,
Pues los dejamos.
Bueno, los dejamos a todos.
Bueno, no, que estén
Estuvo
bien.
buenísimo, a mí me encantó
Sí.
y además lo ideal era que tuviéramos a Bodie contento para que podamos invitarlo otras veces.
Total.
Claro.
Uy, me dio una
Increíble.
pena cuando se me olvidó la pregunta. Yo dije, yo la tenía
Así que nada, feliz
pensadísima.
noche.
Y yo, pues madre, ¿qué pasó? No, me dio el Alzheimer ahí, pero bueno, no pasó nada.
Bueno, nos vemos. Chao.
Bueno, chao,
Chao.
muchachos.
Chao.